Let's take a look at how easy Redpoll Core technology makes it to ask and answer questions about your data. The first thing that we're going to do is we're going to upload a data set. This is the satellites data set. Each row is a satellite and each column is a feature of a satellite. We see that there are numerical values like period and minutes, so the amount of time that it takes for a satellite to orbit the Earth. We see that there are categorical and string types like class of orbit and purpose. We also see that there are a lot of missing cells, a lot of missing data. We're not going to worry about filling those in. We're not going to worry about re-encoding the string data. We're just going to throw it over to Core and see what it comes up with. So here Core has given us a representation of the missingness of the data. We see that there are a lot of missing data. The white cells are missing. In fact, there are several columns for which most of the data are missing. We also see that Core has picked up on a couple of different data types. So there's categorical types and continuous or numerical types. Core is just asking us to check its assumptions because it knows that we know more about the data than it does. Everything here looks good, so I'm going to go ahead and click Approve. And now we have an interface to start asking questions. And the first question that we should ask is, of course, which questions can we possibly answer? So to that effect, we'll render a pairwise dependence matrix. This tells us for each column pair the probability that a statistical dependence exists. So things in black cells we can predict. So we could predict the period in minutes from the class of orbit. We could predict the launch site from the country of operator. But we couldn't predict something in a white cell like the class of orbit from the country of operator. And that might sound like a bummer, but it's really good to know where not to waste your time. We can also render this as a graph because it just looks cool. And now that we know what we can predict, let's do some prediction. We'll go ahead and predict the period in minutes of any old satellite. And here we have a visualization of that. Core is saying that if it had to guess, it would guess about 101 minutes, but it has a high uncertainty. So uncertainty goes from 0 to 1, 0 meaning that there's only one way to model a prediction, 1 meaning there are several ways to model a prediction and they all completely disagree. And we can kind of see what that looks like. There are a couple of peaks here. So as a decision maker, what this is telling us is that Core doesn't have enough information. We need to give it more information. So we'll give it, say, the class of orbit. We'll call it a geosynchronous satellite, add that condition, re-render, and we see the uncertainty has gone down considerably, and the prediction has changed to 1435 minutes, which is just shy of 24 hours. We can also predict categorical values, which in machine learning land is called classification. So we'll do classification on the class of orbit. Again, this is any old satellite, and since most of the satellites in this data set are low Earth orbit, Core is inferring that the class of orbit is probably low Earth orbit, and it's got a high uncertainty again. Let's give it more information. We'll do the opposite prediction of what we just did. So we'll predict, given the period in minutes, call it 1440, which is 24 hours, add that condition, go, and now the uncertainty has gone way down. It's about 1.6%, and the prediction has changed to geosynchronous. What Core is doing behind the scenes is it's attempting to learn an intuitive model of the process that generated your data. And because it has an intuitive model of the data, it's easy to intuit which data don't adhere to that model. But differently, it's easy to find weird stuff. So let's find some satellites that are weird or surprising with respect to their expected lifetime. Here we use a metric called surprisal, which is a measure of how far away a datum is from our expectations. Here we see the International Space Station. It's a low Earth orbit satellite with a really high lifetime. In fact, it has the highest lifetime in this whole data set, which is weird. But we know the context around it. Core doesn't. So we know that this is okay. It's an anomaly, but it's okay. Milstar DFS5, though, that is weird, and it has a 0 expected lifetime. That is most likely a data entry error. We're going to hop over to Wikipedia and see what that should be. Milstar satellite should have a design life of 10 years. Okay, so that's an error, and you might be thinking, great, we get to go and open up the spreadsheet and fix that cell in the file, and then we get to re-upload and retrain and redo everything that we did. Well, we don't. Core is a humanistic technology. And just like you don't have to dump your brain out and start learning from scratch every time you discover a misconception, neither does Core. We're just going to go to edit data. We're going to go to overwrite. We're going to change this 0 to a 10. We're going to click OK. And now we can rerun the exact same query again. And Milstar DFS5 is gone because we corrected the error, we corrected the misconception, and that knowledge propagated through the system. So we saw in the past few minutes, we uploaded an unprocessed data set. We discovered which questions we could and could not answer. We created 4 prediction models. We found and we corrected a data entry error. And we updated our knowledge with that corrected data in real time. This is how Redpoll Core technology can help you to save months or years in data science discovery. For more information, visit redpoll.ai.